C21 polarized capacitor, and this is ceramic capacitor, the motherboard C21, a chemical capacitor. But for this C22, this is a ceramic capacitor. They have the same shape, as you can see. This is diode, we have D, and here, as you can see, the same component, but we have the reference is Q, as you can see, D1006 with, as you can see, the blue line, as you can see here, normal diode is with the black line, as you can see, D1007. So we're going to see the charge IC circuit in the laptop motherboard components, okay? So this is the charge IC circuit. As you can see, we have here DC battery changer, okay? So we're going to see the component that may be failed in the charge IC circuit, okay? We're going to see all this component in the circuit diagram and in the motherboard. So as you can see here, this is the motherboard that we will work on. So we're going to see all these components in the schematic and in the motherboard. So we will begin with the power jack, as you can see, the DC jack or the power jack. Here in the motherboard, as you can see, this is the power jack in the motherboard, as you can see. Then we have here the inductor. Here in the motherboard, this is the inductor, as you can see, near to the power jack. Then we have ceramic capacitors, as you can see, 4 ceramic capacitors. So here in the schematic, we have 4 ceramic capacitors, the same as the motherboard. Here we have the MOSFETs or switches. As you can see, also in the motherboard, we have here 2 switches, as you can see, near to the power jack. And here we have diodes. So for diodes, there is many type of diodes. We have this diode with this line, straight line, and this other diode. As you can see, many types of diodes. We're going to see all these diodes. So here in the motherboard, as you can see, we have this diode, as you can see, with the black line, the cathode with the black line, as you can see. This is normal diode. This is not Zener diode. Okay? This is normal diode. And here, this one is the Zener diode, as you can see. And here also we have another diode with 3 terminals, okay? We're gonna see all these diodes, so this is the reference for this diode. So let's see it in the motherboard. So, as you can see, D1006 with, as you can see, the blue line, as you can see here, normal diode is with the black line. As you can see, D1007, okay, a normal diode with a straight line, and D100 or 1006 with the blue line is the Zener diode. As you can see, D106. This is the Zener diode, as you can see, to stabilize the current, and here we have D1007. This is a normal diode, but basically the same measurement. If you want to check this diode, you should use the same working principle. You can use the multimeter with the continuity option. Okay, so we're gonna see another type of diode, as you can see, with 3 terminals. As you can see, we have 3 here, means 3 terminals. Okay, this is another type of diode. This is like a transistor, the same shape of a 3-pin transistor. So let's check in the motherboard. So as you can see here, we have D. This is 2 diodes. As you can see, we have D1014 here. Okay, as you can see. So this is diode. These 2 are diodes. Okay, this is not transistor. This is diode. The transistor began with Q, not D. Okay, here we have the Zener diode. All these are diodes. So this is the charge IC. Power management, okay? Here, this is its reference. If you have a bad IC, you should replace it with the same reference, okay? We have U4. The reference in the motherboard is U4. So let's check this charge IC in the motherboard. As you can see, U4, the charge IC, U4, okay? Always U is for ICs, Q for transistors. So as you can see, the charge IC is near to the power jack. Basically, all components, the power components is near to the power jack. So this is the power jack. Here we have capacitors. This is the inductor. Here we have two switches or MOSFETs, and here we have the charge IC. Okay. This is the main component that can be failed in the laptop when you have a idle motherboard or a no power laptop. Here we have another switch or MOSFET. Okay. So you will find this near to the battery. Okay. Here we have the gate, of course. This is another inductor, L2. This inductor is a big inductor, L2, as you can see. Here we have a sense resistor or a current sense resistor, R45. This is 0.015. This is a low resistor. So let's check this component in the motherboard. As you can see, this is L2. Okay, L2 inductor. This is R45 resistor, current sense resistor. Okay, so these two components is next to each other, the same as in the schematic. So as you can see, always we have the power jack. So the power jack and the components, the power components are gathered in the same place in the motherboard. Okay, the same in the motherboard. So here we're gonna see amplifiers, some amplifiers. This is, as you can see here, we have plus and minus. This is an IC with 8 pins. As you can see, we have here 8. So the 8 pins, this is its reference in the motherboard. So let's check that IC in the motherboard. So as you can see, we have U1003, okay, with 8 pins, exactly with 8 pins. As you can see, 4 pins in this side and 4 pins in the other side. Here we have another IC with 5 pins. This is an voltage converter. It will convert a high voltage to a low voltage. We're gonna check it or see it in the schematic. As you can see, okay, this is the input, okay, voltage. It can be the 19 volts, as you can see, the V adapter. This is the V plus, the working voltage, 5 volts for the IC. And here we have the out, the voltage, the out voltage. Okay. Usually the output voltage will be less than the input voltage. And here we have the ground, V minus, as you can see. Here we have a normal transistors, as you can see, with 3 pins, as you can see. Q means transistors, with 3 pins, as you can see here in the schematic. So you should differentiate between diodes with 3 pins and transistors with 3 pins. Always pay attention, because in the motherboard they have the same shape, as you can see. This is diode, we have D. Those are diodes, okay? And here, as you can see, the same component, but we have the reference is Q, as you can see. Q. So pay attention, do not replace a diode with a transistor or a transistor with a diode. You should always pay attention to the reference of the components. So always the diode has a D, and the transistor have a Q, and the IC have a U reference. Okay. Here, as you can see, we have another IC, as you can see here, with 5 pins. Okay, as you can see, with the same working principle as the IC we have seen. This is a voltage converter IC. We have U1001. U1001, as you can see, with 5 pins. Here, the same as this, U1002. Okay? U1001 and U1002. Here, as you can see, we have the input voltage and we have the output voltage. Always, this, we call this an IC, a voltage converter IC. Okay? Or you can call it a regulator, no problem. Always we have the input and the output, as you can see, and the working voltage for the IC. And here we have ground, of course. So this is its model, as you can see, LMC. And here the model for this or reference is LMV, as you can see. So you should replace any failed IC or component with another IC with the same reference. Okay, always same reference. So as you can see here, we have another component. This is a diode, double diode, as you can see, double diode D1010 or D1010. We're gonna see this diode in the motherboard. Okay, so this is a double diode. Okay, two diodes that are connected together, as you can see here in the motherboard. Okay, double diode. We have D1010 or D1010. Okay, so as you can see, the first diode is connected to the second diode here. As you can see, the same as we have seen in the schematic. Here we have other amplifier. As you can see, we have out means amplifier, we have minus and plus, the same as this amplifier that we have seen before. Here we have ground. Okay, this is a digital ground. Of course, there is an analog ground and digital ground. Here, this mark means a signal. So this is the direction of the signal. Okay, this arrow means the direction of the signal. Okay, you will find some arrows from left to right and others from right to left. Means the direction of the signal from the IC to the control chip or from the control chip to the IC, etc. Okay, here we have the normal diodes. This is the other type of diodes with 3 pins. As you can see, always the diodes. We have here ICs, as you can see. This is a blown IC. This is resistors. This black component, SMD component, means resistors. Exactly as we have here in the schematic. All these are resistors. The R means resistor. So here we have ceramic capacitors, as you can see. The ceramic capacitor. This is not a polarized capacitors. Let's see the symbol in the motherboard or in the schematic, as you can see. This is ceramic capacitors with no plus or minus. So this is a normal capacitors, a ceramic capacitors, or PF capacitors. Here we have the power management IC. Okay, these are power management IC. So we have here inductor and resistor. This is a fuse resistor R1059. This is a fuse resistor. We have 0 above it. This is inductor. This is a chemical capacitor or a polarized capacitor. Okay. So for this chemical capacitor, let's see it in the schematic. As you can see, this is plus and minus a polarized capacitor. We have C21, polarized capacitor, and this is ceramic capacitor. This is a filtering capacitor. As you can see here in the motherboard, C21, a chemical capacitor, as you can see. But for this C22, this is a ceramic capacitor.